Hello everyone! I've received a lot of questions about this pigeon recently, so today I'd like to talk about how we breed this colour, extreme dilute or lemon pigeons. The first thing you need to know is that this pigeon is in fact a blue checker. Yes, I said that correctly. She is not an ash red or yellow, she is an extreme dilute blue checker. Before we carry on with the video, it might be helpful to define what we actually mean when we call a pigeon's colour lemon. Usually the name lemon is used to describe a blue pigeon who is also expressing the extreme dilute gene. If you'd like to get a better understanding of the base colours in pigeons, make sure you've watched my pigeon genetics episode on colours, patterns and modifiers. The extreme dilute gene modifies the pigeon's feather colour to such an extent that it can actually be difficult to determine the base colour. I know that this hen has a blue base colour because I know the colour of her parents, and because I'm able to see a very faint bar across her tail. You might not be able to see it on the video, but it is there. If she were an ash red pigeon, there would be no tail bar at all. So how do we breed a pigeon like this? Like I said earlier, we need the gene called extreme dilute. Some people also prefer to use the name ecru for this gene. This is a different gene to the regular dilute gene that produces a yellow pigeon when combined with an ash red base colour. That is important, so I'll repeat it again. Although this bird looks similar to a yellow pigeon, extreme dilute is a different gene. You cannot create a lemon pigeon using the normal dilute gene. You need the extreme dilute gene. Crossing a yellow pigeon with a white or a grizzle will not produce lemon. Lemon and yellow are different colours caused by different genes. Like the normal dilute gene, extreme dilute is a sex-linked recessive mutation. This means that the gene is carried on the Z chromosome, and it is much easier to breed a lemon-coloured hen than a cock. Remember, cocks have 2 Z chromosomes, whereas hens only have 1. This means that to produce a lemon cock, it needs to carry 2 copies of the gene, but a cock who carries only 1 copy can produce a lemon daughter, because hens only have 1 Z chromosome and only need 1 copy of the gene to express it. Some breeders have found homozygous cocks to be weaker and difficult to produce, but the easiest way to try to breed one would be to take a lemon hen and pair her back to her father, or pair a lemon hen to her son. We know that if a cock produces an extreme dilute daughter, he definitely carries the gene, as does any cock produced by a lemon hen. So mating them in this way gives a 50% chance of the genes combining to create a homozygous cockbird. Other breeders have had no trouble breeding homozygous cocks, and it is possible that there are actually multiple different forms of the gene worldwide. Extreme dilute does appear to have mutated at least 4 different times, in Africa, Australia, Europe and North America. It needs to be noted that lemon pigeons do have poorer vision than their wild-type loft mates. Inside the pigeon loft they are quite capable, being able to eat, drink and breed without trouble, but it is generally not recommended to fly or race these birds, because they do struggle to see in full sunlight, and are very easily lost. Because of this, they are more of an interesting genetic curiosity than a genuine performing bird. Heterozygous cocks who carry the gene do not appear to have any vision problems though, and are perfectly capable of racing or flying. So to recap, extreme dilute is a distinct gene, and cannot be created by combining any different colours together. Lemon is the combination of extreme dilute on a blue base colour, and is an entirely different colour than yellow. Extreme dilute is a sex-linked recessive trait, so any hen who carries the gene will always express it and pass it on to her sons. Cocks are able to carry a copy of the gene without expressing it, and can pass it on to their sons and daughters. If you have any questions about this, or any other pigeon genetics topic, please leave them in the comments, or visit my Patreon page, linked in the description. I answer all of the questions I get through Patreon, so that is the best way to reach me directly. If you found this video helpful, please feel free to share it with a friend. Thank you.